Now let's look at the bearing capacity of a soil. Each layer has a bearing capacity depending on the type of soil, the volume of air or water between grains. The allowable bearing capacity of a soil is the maximum unit pressure a foundation is permitted to impose vertically or laterally on the soil mass. To depict this succession of layers or strata called horizons, geotechnical engineers draw a soil profile, a diagram of vertical section of soil from the ground surface to the underlying material, using information collected from a test pit, which can be 1 or 2 meter width, maximum 4 meter depth. It can be done by hand or a machine, or boring. Boring is done with a machine. It can go up to 30 meter depth and a much more narrower diameter. Coarse-grained soils have a relatively low percentage of void spaces and more stable as a foundation material than silt or clay. Clay soils in particular tend to be unstable because they shrink and swell considerably with changes in moisture content. If the bearing capacity of a soil is not enough for the mass of the building, then it can collapse. The groundwater is defined as the water table. Water table is the level beneath which the soil is saturated with groundwater. Some building sites are subject to seasonal fluctuations in level of groundwater. Coarse-grained soils are more permeable and drain better than fine-grained soils and are less susceptible to frost action.